Alrighty, this is our last little section, function notation. So we have typically always written our functions as y equals, some junk with some x in it. So there's another way that we can write this called function notation. And when we write function notation, all we're doing is we're replacing that y with f of x. So we have f of x equals 4x minus 1. And again, like I said, we're going to read this as f of x. X is still our input, and f of x is now our output. So what we can do with this now is that we can evaluate it. So you'll see here, this is our function notation. And inside, we have -7. What that means is, hey, take your x and replace that with -7. So let's do that here. So I have 4 times -7 minus 1. Well, 4 times -7 is -28 minus 1, which will give us a final answer of -29. When we write our answers, we are going to write them like this. So f, what we replaced our x with, and then what our final function value would be, which here would be -29. All right, so let's do some more examples. So right at this point, you may want to pause the video and see if you can try a couple of these. If you still like to practice along, go ahead. But at some point, I would pause the video, try some, and then double check your answers. All right, so with this one here, again, we're going to replace our x with 5. So that becomes 5 plus 7, which we know is 12. And again, writing my final answer of f of 5 equals 12. All right, let's try another one. So here, again, I'm going to replace my x with -3. So that gives me 3 times -3 minus 8. You want to use your order of operations. 3 times -3 is -9 minus 8, which will give us -17. Once again, g of -3 equals -17. Okay, let's try some harder ones. This one now involves a fraction. Same steps as we did before, replacing our x with 9. So we have 2/3 times 9 minus 1. Just plug that 2/3 times 9 into your calculator. When you plug that into your calculator, you'll get 6 minus 1, which gives us 5. So that gives me my final answer of h of 9 equals 5. I'm going to give you the answer here for 4. 4, you're going to have f of -4 equaling 20. I'm going to go over 5 with you, so we're going to plug in 5 in for x. So I have -5 squared plus 6 times 5 minus 4. Now, according to our PEMDAS, we have to do exponents first. So we do that 5 squared. We're going to bring down our negative, which gives us -25. I'm going to do my multiplication while we're here, so that's 30. Then minus 4. This is all adding and subtracting, so I can go straight across. -25 plus 30 is 5. 5 minus 4 is 1. Once again, finishing off my f of 5 equals 1. 6, again, you're going to plug in -8 in there. You should get g of -8 equals 13. If you ever get a wrong answer, please let me know, and we can work it out together over Zoom. 7 will work out together. So we're going to have 2 times -5 squared plus 4 times -5 minus 9. Again, this is why it's really important when we're plugging things in that you really need to put them in parentheses. Because here, the difference between this one and this one, the negative was outside on this one. The negative is inside here. So negative 5 times negative 5 is 25. So that gives me 2 times 25 plus, I'm going to go ahead and do that. That one's 20. That's a negative 20, so I'm going to make that minus 20 here. And then minus 9. 2 times 25 is 50. 50 minus 20 is 30. 30 minus 9 is 21. So we have f of negative 5 equals, 21. 8. So we're going to plug in our negative 7. Now these are absolute values. Remember, inside the absolute value, we simplify all the way, and then we take the positive number. Okay, so we'll square it first. Negative 7 squared is 49. But we have the negative on the outside, so we're going to keep that negative. Negative 7 minus 49 is negative 56. And the absolute value of negative 56 is positive 56, which is g of negative 7. All right, let's continue on to the next page here. We're going to skip 9 and 10. We're not going to be plugging in anything like that that's crazy. Now, 11, 13, I switched up a little bit. So if you want to just go ahead and write these in real quick, and we'll talk about these. So with these ones, when you have the number now outside of our f of x, we're going to replace what that f of x is. So this will now become 8. So we will get 8 equals 8 minus 3x. And from here we just solve. So I'm going to minus 8 to both sides. So that gives me 0 equals negative 3x. Divide both sides by negative 3. So I get 0 equals x. I'm going to do the same thing now with 23. So again, instead of putting f of x, I'm going to put 23 equals 8 minus 3x. 23 minus 8 is going to give me 15 equals, there we go, equals negative 3x. Divide both sides by negative 3, so you get negative 5 equals x. Okay, for 15, it wants us to now plug in negative 13. So once again, negative 13 equals 8 minus 3x. Negative 13 minus 8 will give us negative 21 equals negative 3x. Divide by negative 3, so I get 7 equals x. So there's kind of the difference. When you have f of x equals a number, you want to solve for x. When you have f of a number, then you just simplify. Or you can also say plug in to your equation. Okay, here we have h of x. So now I'm going to use my equation h. So that's going to be 39 is equal to negative 5 halves x minus 1. All right, so I'm going to add 1 to both sides. That gives me 40 equals negative 5 halves x. Remember, when we have fractions, we're going to flip and multiply. So I'm going to multiply both sides by negative 2 over 5. So straight across, that gives me 80. Negative 80 divided by 5 gives me 16. So I have negative 16 equals x. Now, of course, there's always going to be word problems, so let's try this one out. Anthropologists use the length of a certain bone of a human skeleton to estimate the height of a living person. One of these bones is the femur, that's in your leg, to estimate the height in centimeters of a female with a femur length of x. So here's that equation that they typically is going to use. Find h of 46. So we're going to plug in 46 in for x. So that's going to give me 61.41 plus 2.32 times 46. Okay, I'm going to keep solving that. So when I multiply these two, I'm going to get 61.41 plus 106.72. Add these two, and I'm going to get 168.13. So that means if they find a bone that is 46 centimeters long in their femur of a female, they would estimate that female to be 186.13 centimeters long. Tall, I should say. Lovely. All right. Let's look at graphs and how we can do this with graphs. So with graphs, again, remember, inside is representing our x. That's our input. This is our x, where we're going to find them. So I'm going to give that a little darker color there. Maybe a little skinnier. Perfect. Okay. So f of negative 3, that means I'm going over to negative 3 on my x. And I would like to know, where does my line touch x? Or what is my y coordinate when my x is negative 3? Looks to be right about there, which is going to be 2. Okay, let's do that again. F of 1. So I'm going to go over to 1 on my x coordinate. Okay, so where does that touch? Well, hey, that touches also at 2. Okay, let's look at another one. F of 0. So I'm going to go, again, up and down on 0. When my x is 0, my y is right here. So that's 1, 2, 3, 4, 5. All right, let's try one more. So f of 2. So I'm going to go over to 2 on my x. Go up and down. So where does my line touch that? Right here at negative 3. Now, we've done only when our x inputs. We can also plug in y. So this is when our y is equal to 2. So I'm going to go across to my 2 here. And look, this one, in fact, has 2 choices. So when f of x is 2, I'm going to get the answer of 1 to negative 3 and also 1. Nifty. All right, let's try one more example. So here again, f of negative 4 means go over to negative 4 on your x and tell me where my line hits. My line is hitting right there at 2. F of 2 is at 2, so we're going to draw our line again and see where it hits. This one happens to hit right here at negative 2. F of 0 is when x is 0. We're going to draw our line. That's at my origin, which means that is also 0. F of 5, so I'm going to go over to 5. Draw my arrow up. Whoop. Draw my line up and down. That time it's hitting right here at negative 1. All right, here comes a tricky one. Okay, this one is asking now, when does y equal 0? So here's when y is 0, so I'm going to draw that line. I have to tell all of the points where y is 0. So it's here, it's here, and it's here. So let's kind of estimate. So that's a little bit after 5, so maybe negative 5.3. We're also here at the origin at 0. And here, 1, 2, 3, 4, 5, a little bit after 5, so maybe positive 5.3. That is all the times when our y is equal to 0. All right, if you have any questions over today's notes, please let me know, and then do the assignment listed above. Have a great day, guys.